Hi, Sal. Come on into my office. Please close the door behind you. I want you to know I had you come today because you're actually up for tenure. You've been here for a few years. Students really like you a lot. You're the most popular teacher we have in school right now. And since you've been doing this for a few years, you're up for tenure, and I'm going to go through one of your lessons with you and just show you, point out some of the things that you could improve to be an even more effective teacher. So grab a seat and let's get started on this lesson that I saw in your video today having to do with absolute value equations.
Let's do some equations that deal with absolute values. And just as a bit of a review, when you take the absolute value of a number, let's say I take the absolute value of -1. What you're really doing is you're saying how far is that number from 0? And in the case of -1, if we draw a number line right there, that's a very badly drawn number line. So if we draw a number line right there, that's 0. You have a -1 right there. Well, it's 1 away from 0. So the absolute value of -1 is 1. And the absolute value of 1 is it's also 1 away from 0. It's also equal to 1. So on some level, an absolute value is, it's a distance from 0. But another, I guess, simpler way to think of it, it always results in a positive version of the number. The absolute value of -7,346 is equal to 7,346. So with that in mind, let's try to solve some equations with absolute values in them. So let's add the equation. The absolute value of x minus 5 is equal to 10.
Okay, Sal, well, looking at what you've done so far, I think your introduction has been pretty good, this idea of distance from 0. And now you've moved into your first example. Now this example, absolute value x minus 5 equals 10, might be skipping an opportunity to do sort of an easier question first. In teaching, we call this scaffolding, where we sort of build up from an easy question to a more difficult question. I think a good starting question for you would be just the question absolute value of x equals 10, to enable students to see that there's two answers to that question, 10 and -10. And that would go well with the explanation of absolute value that you just introduced.
And one way you can interpret this, and I want you to think about this, this is actually saying that the distance between x and 5 is equal to 10. So how many numbers that are exactly 10 away from 5? And you can already think of the solution to this equation, but I'll show you how to solve it systematically.
Okay, Sal. So with that last explanation about how to think about absolute value, I think you're trying to do a little bit too much right now in this lesson. You've just done a nice explanation of absolute value in the beginning, where you defined it as distance from 0, which is going to be really useful in solving equations like this. But you just introduced very quickly another interpretation, which is when you have an equation like this, where it's absolute value of x minus something equals something else, we can interpret it, in this case, as numbers, what numbers are 10 away from 5. But that's going to be pretty confusing for students because you just explained it in a totally different way. And though this new way might give them some more depth of understanding, it's more likely right now to confuse them. I want you to be careful about that.
Now, this is going to be true in two situations. Either x minus 5 is equal to positive 10. Right? If this evaluates out to positive 10, then when you take the absolute value of it, you're going to get positive 10. Or x minus 5 might evaluate to -10. If x minus 5 evaluated to -10, when you take the absolute value of it, you would get 10 again. So x minus 5 could also be equal to -10. Both of these would satisfy this equation. Now, to solve this one, add 5 to both sides of this equation. You get x is equal to 15. To solve this one, add 5 to both sides of this equation. X is equal to -5. So our solution, there's two x's that satisfy this equation. X could be 15. 15 minus 5 is 10. Take the absolute value, you're going to get 10. Or x could be negative 5. Negative 5 minus 5 is negative 10. Take the absolute value, you get 10.
So I hope you see what I'm talking about, what I was talking about before. You went back to the original definition of absolute value in your way of solving this question, and I think you did a nice job explaining it, and that part's good. So I think, like I said before, just cutting out that alternative explanation might make this a little less confusing for students. Okay, let's see what you did next.
And notice, both of these numbers are exactly 10 away from the number 5.
So here you've brought up that alternate definition again, which if you really want to have that other definition, you'll have to really explain it more clearly in the beginning of the lesson. Because at this part where you mention and take a look, it's this, both of the answers were 10 away from 5. I don't think that students would really be making much of a connection between the process you just solved and why that ended up becoming true at the end. Okay, let's see what you did next.
Let's do another one of these. Let's do another one. Let's say we have the absolute value of x plus 2 is equal to 6. So what does that tell us? That tells us that either x plus 2, that the thing inside the absolute value sign is equal to 6, or the thing inside of the absolute value sign, the x plus 2, could also be negative 6, right? If this whole thing evaluated negative 6, you take the absolute value, you'd get 6. So, or x plus 2 could equal negative 6. And then if you subtract 2 from both sides of this equation, you get x could be equal to 4. If you subtract 2 from both sides of this equation, you get x could be equal to negative 8. So these are the two solutions to the equation.
Okay, well, that part was pretty good. So let's see what happened next.
And just to kind of have it gel in your mind that absolute value, you can kind of view it as a distance, you could rewrite this problem as the absolute value of x minus negative 2 is equal to 6. And so this is asking me, what are the x's that are exactly 6 away from negative 2? Remember, up here we said, what are the x's that are exactly 10 away from positive 5, right? Whatever number you're subtracting from positive 5. These are both 10 away from positive 5. This is asking, what is exactly 6 away from negative 2? And it's going to be 4 or negative 8. You could try those numbers out for yourself.
Now you see there you tried to bring back in this other way of thinking about absolute value. And I want to make it clear that it's not that that other way of thinking about absolute value is bad. It's just that you have to make a decision. Do you want to do both of these simultaneously? And if so, you have to be really careful about not making it confusing, because this explanation was a little rushed, and I think this would confuse kids. They're just beginning to get this sort of algorithm for getting the answer, and when you rewrite x plus 2, absolute value of x plus 2 equals 6 as x minus negative 2 equals 6, and now say we're looking for things that are 6 away from negative 2, there are ways to make a lesson out of that other approach, and it would have to be developed pretty carefully. But right now, that's really just taking away from the lesson. Let's see what you did next. I'm going to speed up this next part. This other example is good. You introduce fractions, and no problem with this. Very good.
Let's try to graph one of these just for fun.
Now, this is getting a little bit too ambitious now to add in a full new topic in here of graphing equations in two variables. You would be better off ending this lesson here and giving students an opportunity to practice it. And I do admire ambition, trying to get as much as you can into the lesson, but students only are going to sort of digest so much at one time. So I think adding this in weakens this lesson. Okay, let's see what you do next.
So let's say I have y is equal to the absolute value of x plus 3. So this is a function or a graph with an absolute value in it. So let's think about two scenarios. There's one scenario where the thing inside of the absolute value is positive. So you have the scenario where x plus 3, I'll write it over here, x plus 3 is greater than 0. And then you have the scenario where x plus 3 is less than 0, right? When x plus 3 is greater than 0, this graph or this line, or I guess we can't call it a line, this function is the same thing as y is equal to x plus 3. Right? If this thing over here is greater than 0, then the absolute value sign is irrelevant. So then this thing is the same thing as y is equal to x plus 3. But when is x plus 3 greater than 0? Well, if you subtract 3 from both sides, you get x is greater than negative 3. So when x is greater than negative 3, this graph is going to look just like y is equal to x plus 3. Now, when x plus 3 is less than 0, in the situation where the inside of our absolute value sign is negative, in that situation, this equation is going to be y is equal to the negative of x plus 3. How can I say that? Well, look, if this is going to be a negative number, if x plus 3 is going to be a negative number, right? That's what we're assuming here. If it's going to be a negative number, then when you take the absolute value of a negative number, you're going to make it positive. That's just like multiplying it by negative 1. If you know you're taking the absolute value of a negative number, it's just like multiplying it by negative 1 because you're going to make it positive.
Now, this idea you just described about how the absolute value of a negative is the same thing as negating the thing itself to turn it positive, that's quite confusing in this sort of abstract way where you're doing absolute value of x plus 3. I think you could set this up even earlier in the lesson, even right in the beginning of the lesson. Again, I don't think this whole graphing thing belongs in this lesson, but let's just say that you had a long time and you wanted to put that into this lesson. You might set it up by, in the beginning, saying, the absolute value of 5 is 5. So for positive numbers, the absolute value is itself. Whereas the absolute value of negative 5 is positive 5, which is the same thing as negative 5. Introducing stuff with sort of a concrete number instead of sort of an abstract expression like x plus 3 makes it easier for the kids to understand. Okay, let's see what you did next.
And this is going to be the situation. This is the x plus 3 is less than 0 if we subtract 3 from both sides when x is less than negative 3. So when x is less than negative 3, the graph will look like this. When x is greater than negative 3, the graph will look like that. So let's see what that would make the entire graph look like. Let me draw my axes. That's my x-axis. That's my y-axis. So just let me multiply this out just so that we have it in mx plus b form. So this is equal to negative x minus 3. Negative x minus 3. So let's just figure out what this graph would look like in general. Negative x minus 3. Negative x minus 3. The y-intercept is negative 3. So 1, 2, 3. And negative x means it slopes downward, has a downward slope of 1. So it would look like this. It would look like this. The x-intercept would be at x is equal to, so if you say y is equal to 0, that would happen when x is equal to negative 3. So it's going to go through that line, that point right there. And the graph, if we didn't have this constraint right here, would look something like this. It would look something like that. That's if we didn't constrain it to a certain interval on the x-axis. Now this graph, what does it look like? Let's see. It has this y-intercept at positive 3, just like that. And where's its x-intercept? When y is equal to 0, x is negative 3. So it also goes through that point right there and has a slope of 1. So it would look something like this. That's what this graph looks like. Now, what we figured out is that this absolute value function, it looks like this purple graph when x is less than negative 3. So when x is less than negative 3, that's x is equal to negative 3 right there. When x is less than negative 3, it looks like this purple graph right there. So that's when x is less than negative 3. But when x is greater than negative 3, it looks like the green graph. It looks like that. So this graph looks like the strange v. When x is greater than negative 3, this is positive. So we have the graph of, we have a positive slope. But then when x is less than negative 3, we're essentially taking the negative of the function, if you want to view it that way. And so we have this negative slope. So you kind of have this v-shaped function, this v-shaped graph, which is indicative of an absolute value function.
Okay, Sal, so that was your lesson. And in general, it was a pretty good lesson. It had some small adjustments that I think would have made the lesson stronger, be less confusing, kids could learn a little bit better. But all in all, you should be happy that you show a lot of potential, and these are small things that are pretty easy to correct. So I am going to recommend that you get your tenure, because the potential you have and your constant learning and improving, I really appreciate that, your hard work. So keep up the good work, Sal, and you can always email me if you need any advice.